Well, this bed was the first bed we tried to put together, to put the jigsaw together so we could reconstruct a whole section of seafloor. But it's actually not the seafloor. This is a thick layer of sand that had buried an formerly existing seafloor. And you can see these grooves, big broad grooves going through here, which is actually the top of a giant ripple that was on the seafloor beneath it. And lying on those pre-existing ripples were these creatures called Dickinsonia. And they're preserved because the sand that buries them was lithified very, very early. We think that this top reddish layer had a thin veneer of fool's gold or iron pyrite, which developed over the underlying seafloor because there was organic matter all over the seafloor. You bury it with a layer of sand and then seal that sand off with another organic layer, and you've got something like, plastic food wrap sandwiched in between layers of sand. And that organic matter decays, and bacteria takes iron out of the sediment and sulfur from seawater, and you get iron sulfide or fool's gold. And that normally looks kind of literally a goldy colour, but in these rocks we see no trace of that original pyrite, that iron sulfide. The reason is that in Australia the rocks have been sitting here for so long that oxygen from the atmosphere and water get together and leach right down through these rocks and change all of the chemical composition. So this was originally made of sand, particles of sand which were loosely cemented together. Then over time, as these rocks were pushed up to the surface, rainwater leaches down through the ground and dissolves some of that silica and moves it around. And so in some places we find really hard rock like this, and in other places it's crumbling away. And we can even see on this rock where it's fretting away. The surface looks like it's got tooth decay. So it frets away. And in some places you can break the rock with your hand. All of this means that in between the fossils being preserved around about 500-600 million years ago and the present, these rocks have suffered lots of changes. And the last change is what we call weathering. Weathering is where chemicals from rainwater and acids from decaying plants alter the chemistry of the soil and move the ions around, so that sometimes the rocks are preserved as hard sheets and sometimes they just break up in your hands. And one of the problems here is as we dig into the ground, the rock doesn't get harder, it gets softer. That we didn't expect, and it creates real problems. So along this slope, as you can see, all these layers of rock look fantastic. When you go too deep, they become really quite sugary. They're turning back to their original structure, which is sand. That makes the sandstone. And those grains will end up in the creeks below us and be washed out and be deposited somewhere else, and the fossils will be lost. But if you turn these rocks upside down and get them away from the soil and the organic matter, they'll probably preserve for a very long time, because the desert is a great place when there's a lot of sunshine and not much in the way of lichens and bacteria to eat the rocks away. Therefore they've got a good chance of surviving, provided they're not collected.